think we're live. So... Okay, let's see what we got today. Netflix lays off 150 employees. That's probably the what's it called, the recruiting department. Got into Twitter after years of not getting it. What's this? Martin Boss. Who's Martin Boss? I was once a developer, product creativity. Be a transparent manager. I don't know. I'm gonna kind of like ignore this one. I don't know. I usually just like reading the technical stuff. What else do we have here today? South Korea turns to surveillance as ghost surgeries shake faith in hospitals. What? Ghost surgeries? What the heck are ghost surgeries? Which, after scandals in which doctors let unsupervised assistants operate on patients. Oh, seriously? Shit. Holy fuck. Unsupervised assistants are just performing it for the doctors. That is pretty whack, yo. Move would help protect patients. Okay, so it would be to try and limit malpractice. All right, fair. Ooh, okay, so, interesting. Ghost doctor and you get caught. Okay, so I get it. My question now is, what is the argument against this? Demand for the camera, revelations that even whistleblowers that doctors had inflicted ghost surgeries and sexual abuse on anesthesized patients. Okay, I see. What's the other side to this? Spread to spinal hospitals because of a confluence of factors. There's an undersupply of doctors that to meet the demand. Okay, got it. So they do it to meet the demand for patients, so that way the assistants actually do the procedures for them. Interesting. Hey Justin, what's up? Let's see. Video hospital shows nursing assistants performing incisions and putting in sutures. Okay, malpractice, blah, blah, blah. Got it. They're treating patients like objects on a conveyor belt. Okay, I get it. So then what is... I'm kind of curious, what is the argument against monitoring? You just finished the first week of your internship. Nice, man. How'd that go? Doctors can refuse for certain reasons, delay an operation that would put the patient's life at risk. Okay, advocates for patients say punishment for ghost surgery is too lenient. Doctors can fines and 5 years, and then reapply after 3. I don't know. Malpractice is a pretty bad stain, especially if it's on a record. So, Yes, ghost surgeries are very profitable. Okay, that makes sense. 10 to 20% of hospitals are for profit. And private hospitals in South Korea are over 90%. Okay. Okay. I don't know. The article is a little bit too long. I get why they're doing it, but it's like, um, it's just it's felt one side. What's the argument against it? I don't feel like there is an argument against it. To be fair, it's like if there's malpractice going on, then you kind of want to monitor it or at least have a deterrent to it. So I'm not against it. I'm just like, well, I would like to hear if anyone's against it and why. So mostly onboarding and trying to create a design document. Yeah, I think that's pretty normal. Although creating a design document is kind of weird. I thought they would kind of give you like small bugs and tasks to try and do. Tech companies are censoring the violent crackdown on Iranian protesters. Oh shit. The Minsky moment for venture capital. Uh, I don't know. I'm gonna skip that one. New York has more Airbnb listings than apartments for rent. Holy crap! Okay, this one I want to read. The fever isn't breaking. There's now bidding wars for 1 in 5 Manhattan rentals. There are, which is several thousand less than the entire. Holy shit. There have been concerns that short-term rental companies would deplete the housing stock. Yes. I've seen this actually. Airbnb, I have seen even in my neighborhood, there's a lot of rentals, even when there shouldn't be. So it's kind of interesting. I think the Airbnb industry and like renting out your own home, it's I don't know how do I describe this. It's like I get why it exists. I have very mixed feelings about it. Because for one thing, is it profitable to rent out your home like that? Yeah. Is it but it's like who but it's like the people who would buy those rentals, would they live in it as well? Or is it just people who are like, "Hey, I want to rent on Airbnb as well?" I don't know. Yeah, the entire space listing supply citywide has decreased and now represents a fraction of the percent of the city's rental units. All while rent prices have trended upwards and city issued permits for new development rate down by a double-digit percentage. That number was somewhat gamed, comparing its inventory to the total number of rental units, not just available ones, which was okay. I see. Company has always vehemently denied that it plays any role in the housing shortage. Well, the thing is that you do by nature, like just by nature of the incentives right there. Now the question is, how much housing shortage do you cause? Because there's always an incentive to just buy the unit and then rent it out. That's undeniable. The question is, how much does that occur? Multiple listings for the same property and listings that show up as active but are rarely available. A townhouse that homeowners only rent out when they travel, meaning it's active year-round but only available for a few weeks a year. Okay, that's fair. Even if Airbnb and Inside overestimate the number of apartments and by a wide margin, blah, blah, blah. So they're denying it by kind of... Okay, I get why they're denying it. It's like saying, oh yeah, most people are just renting it out on their spare time. How far in advance would I schedule an on-site interview? 6 weeks. And by then, you'll know immediately, like, whether or not you're ready. I think for me, whenever I schedule interviews or recommend people schedule interviews, they should be at a point where they can get a pretty much 60 to 80% hit rate for leak code questions, essentially. And it's pretty clear to tell whether or not you're there. I mean, then again, my standards are pretty high. But once you start getting somewhere near 60 to 80%, you are pretty much ready to start scheduling interviews. At least for me, so. City's housing market is always tight, close to crisis. You have better luck finding a one-bedroom in Brownstone for a few weeks than a year-long lease. Not likely to change anytime soon, correct. I don't know. I think this is just one story where you actually have to mine the data yourself to see. The next effective medium rent in Manhattan went up year over year to a new high. Holy shit. And listing inventory has the most significant annual decline on record. Okay. Yeah. I think this is one where you actually have to look at the data yourself to figure out. Again, like I said, I don't think I don't think Airbnb can or should deny that they are contributing to the housing shortage because again, the incentives are there. The question is, by how much? So, in Manhattan, you can't get anything decent under a 3.5K for one bedroom. Yeah, that's about right. That's the same in San Francisco as well. So I don't know. I personally don't like the fact that people are how to describe it. That people just kind of like buy and then buy solely to rent and collect money like that. But I mean, it's a thing, right? We're all just at the end of the day when we invest, that's essentially what we try to do. We take away money that's available for someone else to collect and grow. You know, it's a difficult moral argument to really deal with. I think when you really realize what each of your investments mean. You know, like for instance, if you invest in Philip Morris, you're essentially betting that people will smoke more cigarettes. You know, and that's not exactly the healthiest thing. It's like a sin stock. You know, so my friend paid the year before 2,900, no increase to 3,600 now. Yeah, now that the cities are reopening, it kind of makes sense. Anyway, let's bring on my client and see what's up. Hello. Hey,
Yeah, hello.
hey, hello.
Can you hear me?
Yeah, I can hear you. Can you hear me?
Good.
Great, great. Yeah, yeah. Catch me up on like how your practice went.
Um, yeah, the practice, I think I sent you the blurb yesterday, right?
Yep.
Uh, I did two mock interviews with this other Amazon guy, right?
Okay.
Was not my, was a friend of my friend. And like, mm, I'd say like his feedback was good, just like few typos, right? And little things that he
Okay.
said that was nitpicks. But basically, one thing from the past sessions,
Yeah.
like I overcomplicated things, but nothing that he not understand. But one thing is for sure, like my explanations was more clear than before, right? And like, and I've been doing like actually lead code, mm, not as much as I wanted because of this midterm I explained to you, right?
Yep. Yeah, I know you have
Mm,
the midterm coming up. It's basically
yeah,
tomorrow. So.
tomorrow, yeah. Um, and what else? Oh yeah, and I actually asked like a general feedback because I had a four mock interviews with this guy, and one comment that I think was pretty cool. Like he said, you were like one of the persons that were more prepared than I ever saw. You know, so maybe that's a good sign.
Yeah.
And yeah, I think that's pretty much it. And yeah, one last thing. I've actually was training on the mirror, like the behavioral portion, you know,
Mm-hmm.
like to tell my stories in a convincing way. As you mentioned, like I rewatched the stream,
Mm-hmm.
like the stream focused on behavior, right? And that's pretty much it. Like,
Okay. Cool. Yeah. So I'm actually very curious about. Okay, I took a few notes here. A few things. First, I want to see that interview with the Amazon friend. If you have like the sheet for it or something, because he
hold
said
up.
that you said that you overcomplicated some things. That's usually
Uh, yeah.
a sign that you might have gotten lost in your own explanation or something is a little bit unclear. I'm also
Just give me a
looking at
moment.
your
Oh, it's
sorry, I'm also looking at your practice sheet here.
uh,
And I'm kind of seeing that it's a little sparse, but for the past few days, like there wasn't really any errors or comments.
oh
The
yeah,
time
because I was focused on the code.
that's fine. Yeah, yeah, I understand you're focusing on leak code, but I think it's still good to like if you fuck up a little bit on leak code, it's good. It's still okay to like write it
Mhm.
out in your practice sheet.
Uh-huh. Okay,
Um,
so just a minute. I'm gonna put a Google Doc here.
okay, yeah. send it to me.
I found
I feel like, oh yeah, these times are still pretty good actually. Like really, like I see like
mhm.
17, 18 minutes, 27 minutes, 26 minutes, um, 47 network time delay. Okay, I understand why I could take
Oh
36
yeah,
minutes.
the
47.
uh,
This is the one we did, pretty similar to it. Um, yeah, I think okay. These times look pretty good actually. I'm not gonna lie, they're not terrible. It's just a few outliers, but I understand why they can be outliers. So
mhm. Let me just share with you.
yeah, send it to me.
Whatever. I have one of this I found. I'm gonna try to find the other, and I'll send you as well.
Hmm.
The workload has increased drastically. Just close the interview. I don't know why.
For what you're doing or what
School.
school? Yeah.
No, for school, and also like my current job. We're gonna have a migration that's gonna happen Monday. So
Hmm.
yeah,
Okay. Yeah,
and
I
I
understand.
am fixing. I'm like doing some bug fixes right from a legacy code. Oh, it was a crazy
Got it.
times.
Okay, so yeah, let's talk a
Anyways,
little bit about that because this is like we just need the Microsoft interview. We have like basically the way I
for
see it, we have
sure.
like one shot. This
No,
is actually
man, that's
so fucking
definitely the
risky. Holy
goal.
shit! You
Man,
have no
that's
idea how
like
scared I am right now. Actually.
no, that's my. I actually today I talked with the manager, with my manager, just to say that I'm not gonna work right
Uh-huh.
on the Thursday, and she was a little bit hesitant. She said, "Oh, maybe like half of the day, you know." And I said, "Because I need to do some things extra about college and like also I tried to create a story, you know.
Yeah, just say, hey, yeah,
Unfortunately,
you have your
I don't
midterm.
like why she asked why, you know, because we are a migration week.
Mhm.
So, oh man, this must happen in this
So
thing.
okay, let's talk a little bit
Anyways,
about that because I'm trying to let's smooth things over for the next few days. Just say, hey,
yeah.
I need to focus on school for Thursday. I have something on Friday, but I can work Saturday. I think most
Mhm.
people would be okay with that. It's like, okay, as long as you put in the extra time, just offer the alternative.
Yeah, I offer like I can work like late, you know, late work late until 9 p.m. That's not a problem for me. But after Thursday, please,
Yeah,
you know.
just say, yeah, that you're working on school and stuff. I think that's perfectly fine. Just say you'll make up the time later. I don't think people are gonna be, um, uh, offended by that. So it's whatever.
Uh-huh.
Like I said, we're focused on that one day. Now I understand the midterm is going to be something that you need to focus on as well. How prepared are you with that? Because I want to give you extra
Um,
time in case you don't feel prepared.
I'd say I can guarantee the 30% because it like the system is if I am able to have 30% on this first midterm, uh, and I can do the final, you know. And there's like I don't know what term you use in English, but there's like an extra test in case we don't achieve like the necessary grade.
Hmm.
So I'm counting with this, you know, but I cannot be allowed to have 0% on this first midterm.
Okay.
So yeah, I was trying to work with numbers here just to give the best shot without studying that much because focus on Microsoft, you know.
Yeah, yeah.
Uh,
So I think it's fine. Like I think what we're gonna do is after Microsoft, I want you to focus on school because at this point you're basically prepared. As just like make sure you keep up with the practice, and then whatever interviews come your way, it'll be fine.
yeah,
But I'm really hoping we
yeah.
get this. Anyway, so
Mhm.
let's focus on what we can
Oh,
do
yeah.
this week, and then we'll talk about what comes after Microsoft.
Great,
Okay.
great.
So this is
Actually,
go ahead.
let me put a point about this question.
Yeah.
The point was actually, if you see the code, is basically, I'd say good,
Yeah.
but the beginning in the discussion was where I kind of messed up
That's fine.
because like where I was trying to create the idea, I didn't realize that I could use a heap, you
Okay.
know, and that was not good to me because I was trying to overcomplicate my solution,
Yep.
you know, and then I start over, you know, and I start over because he was not understanding where I was going.
Yep.
And then, yeah, by starting over, I kind of figure out that a heap might be used, but I was not good with it because I kind of lost,
Hmm. Okay.
let's say, 7 to 8 minutes, you
Hmm.
know, which is not cool.
That's not good. Yeah. All right, let's go over it. So the problem is like sort case number of arrays, or what the problem is specifically?
You have an array
Yes.
that have numbers k distance apart,
Okay. Okay.
and like you basically need to they're not going to be k distance apart. So you basically need to leverage this specific fact to sort the array.
Okay. So
So
what is this?
basically,
So
go
I don't
ahead.
understand what k distance apart means in this context. So you have this array here, 3, 4, 2, k equals 2. What does that mean?
Hold up. For example, 532, right?
Yes.
I need to sort starting with 0.
Okay.
But if you see here, like imagine that k is equal to, in this case, was like this first example here, 3, 4, 2, right?
Yes.
3 is actually two distance from the actual position, right? That is
Okay.
this last one.
Okay.
So we have 4 and 2, you know. And in this other example here, I guess k was 4. It's here,
Okay.
you know. So 5, it's like there's 3, 2, and 1, and then 0. That is the position of 5.
Okay.
So basically, I fill up a array, actually a
No,
heap,
don't
right?
tell me the answer. I want you to describe why this works.
Oh,
I'm trying to figure out. Like, I still don't
okay.
understand what k distance away means. And what exactly are you sorting? This doesn't even look sorted.
I just didn't catch the last part. The last part.
This doesn't look sorted to me, so I don't know what exactly the problem is still.
Actually, you have to. Yeah, it's not sorted, you know.
Okay. So,
But like, for example, you need to sort, and you know that the elements are k distance apart.
okay.
So you need to try to leverage this fact to
I
sort
don't.
faster.
Okay. Let's start over. I'm not asking you to tell me the answer. I'm asking you to describe the problem to me. I don't understand what the problem is asking.
Okay.
So you say k distance. Is this
Yeah.
5 distance of 5?
Yeah, for every element are not going to be distance from the actual element.
So
From
actual
the
I don't know
actual
what
position.
actual element is. I don't know what you're talking about. Are you saying 5 is the first element and you want to sort all the elements that are k distance away from the first element?
Not for the first, for the real position, you know.
I don't know what real
For the position,
is. Okay.
the position it should be sorted.
Okay. Okay. Let me read this. Sort k sorted array. Write a function that takes a non-negative integer k and k sorted array of integers. Okay. So you have a non-negative k and you have k sorted integers, and returns the sorted version of the array. Okay. Your function can either sort the array in place or create an entirely new array. Okay. So what is a k sorted array? This is what I'm asking. A k sorted array is a partial sorted array in which all elements are at most k positions away from their sorted position. Okay, from their sorted position. Okay. For example, the array 3, 1, 2, 2 is k sorted with k equals 3 because each element in the array is at most 3 positions away from its sorted element. Okay, got it. So an element is sorted if it's k position away from where it should be.
From where it should be.
Okay, so this is what I think I'm starting to see where you might have overcomplicated things. So basically, I kept trying to say I'm trying to understand the problem, and you kept trying to go to the solution. Think about it from my angle. If you did not copy paste this, and I said, "Oh, you need to sort k sorted element," could you understand
that? No, no, actually no.
There you go. So I remember when we talked about the balance between the interviewer and what you need. I think you might have swung a little bit over that because, for instance, when I literally kept saying, I don't understand the problem. I don't understand the problem. This is where you have to go step by step. And I'm sure the interviewer said, I don't understand where you're going with this. Yeah. So when that happens, you need to stop, rewind, and then break it down step by step. Like literally, if the interviewer says, I don't understand, there you've already lost them. Remember, it's all about the logic, step by steps. And there's some things that you can skip, but in this case, when we're just starting with the problem, there's nothing to skip because I don't really understand what the heck's going on. Does that make sense?
Totally.
Okay. So so now I understand what the problem is asking. You're looking to make an array where in their where the elements in the final array can be at most k distance away from their real sorted spot. Okay? So then now the question is, why is there a 5237 here? Let's okay, now that I understand the problem, let's go step by step. Let's replay through how you lost the interviewer first.
I had no idea to solve this problem in the beginning.
No idea how to solve this problem.
So, no, actually, sort, but that was not the brute force solution was not the solution.
Okay.
And I thought about something using shifting elements in 5 distance apart.
Okay.
But I think that was the point I lost the interviewer actually. And because like my line of thought went in the direction of, okay, here I have 5.
Okay.
And I would check if 5 is greater than 3, then 2 and 1. And I'll take actually the minimum between 3, 2, and 1 and 0, and just shift 5 with 0. Kind of doing a shift kind of
like
thing.
A swap. Okay.
Yeah, swap. Yeah.
Okay.
And from the second one, doing the same thing, like comparing with 2 and then with 1, and do another swap.
Okay.
So I was trying to go in this direction, but then I actually tried to break my idea just to see if that worked in all the cases. And then I got confused while explaining. Then I start over,
I see.
Because I saw that the interview was not following my idea.
Okay.
When I break my example. So basically, that was the whole point.
Got it. So the first question is, where does this swapping idea come from?
To use the fact of the k distance. So I was trying to compare with this k distance. So basically, that was it. But then I realized that it would not be good. It's not going to be good in terms of complexity, because every time we need to do a comparison, with k distance away, ahead of the, and soon I realized this.
Okay, so that's where you start. So let's put a pause right there. So the reason why you lost the interviewer is because you basically came out with an idea that was loosely connected to k. So it's like, oh yeah, with k distance, let's just swap elements. You kind of see how that's a little bit random, because I don't know how that solves your problem or gets you closer to the solution. It's kind of like a shot in the dark.
Yeah,
unless you can tell me where this.
I was not sure.
Unless you can tell me, like us, if you've seen a similar problem to this where that solution worked or something like that. I need to see where the genesis of this idea comes from. That's pretty much why you lost the interviewer, I think.
I based myself on the question of the Dutch flag, where you have 3 colors unsorted and you need to sort it. So the most optimal way is to do the swaps. So I kind of base myself on this.
Do you remember the logic for that problem? Like, because no one comes up with the swap right off the bat. What was the logic that allowed you to build up to it?
Actually, the logic was first to sort the zeros, then the ones, then the 3 is going to be sorted by definition.
Yes.
And here we don't have the same logic here. I was just trying to use the swap with the more fetch and pray logic.
Okay,
maybe.
Now I understand where your thinking came from. You recognized a similar problem and you tried applying it immediately. Okay, I understand where it comes from. So your instinct is not necessarily, I would say, wrong. I would say it's like 60% right, 40% wrong. You saw something similar, you tried applying it. Where you went wrong was the fact that not every interviewer memorized every single problem in the book. Like, if you told me, like, how to do Dutch national flag problem, I kind of familiar with it, but I don't know the logic behind it. And that's where you need to come in. That's where you need to, like, basically build the argument from the ground up for the interviewer, why you can use the same pattern from the Dutch national flag problem. Does that make sense?
Yeah, that makes sense.
This is like the context thing we're talking about. It's like, there are some things the interviewer is going to know, some things the interviewer is not going to know. Can the interviewer figure out the logic for why you would use a hash map? Yeah, probably. can the interviewer figure out why he would use a pattern from some really obscure LeetCode problem that he hasn't seen? Probably not. But this is
So
also why, like,
it's my
for instance, like maybe sometimes the interviewer might not even know what a sliding window is. That's like it's a pattern that you know and you can derive. And so sometimes it might be okay. Like, do you know what the XYZ pattern is? If they say yes, then okay, you can jump to it. If it's no, then you can derive it. And so the reason why I'm saying this is because there are some pretty obscure things that might be common to you, that might make sense to you, but it's not to them. And it's a very hard thing to strike a balance. But at least you should always have the ability to derive it for the interviewer in case you lose them. But you should at least say where the idea comes from. So anyway, that's kind of like why you lost a few minutes there. And if you just and so I think also it hurt you because you just kind of jumped to it without seeing the derivation. Does that make sense?
Mm-hmm.
All right, so let's continue. So you lost the first 10 minutes. Okay, it happens. Let's start over. What happened after that?
Actually, he said, I don't know, maybe that's a hint. He said, think about like the range of K. What can you do like in this range,
Yeah.
without shifting?
Okay.
So like basically that. And I kind of gave up of my initial idea.
Yes.
And I saw like just as a magic bullet. Okay, if I take the minimum of it at every iteration, I can get like a sorted array. So basically, yeah, and then I realized then all clicked.
I don't understand what that means.
For example, he said this, right? So if you use like the fact that the elements are not going to be k distance from the position that they should be, what can you do inside of this range, the k range,
Okay.
What can you do? He just asked me this question.
Okay.
And then I answer, well, maybe I can take the minimum of it, right, and place in a result array.
And
he said, yeah, that's it.
Array?
The minimum of the range, of like the range ahead of it,
Okay.
Yeah. And then I realized, okay, so for every time, for this moment, okay, let me start over the array here, the original. So starting from this, okay, so with the k equals to 4, whatever, because that was the.
Oh, I understand. Now I understand where you're going. So I know what you're doing now.
Yeah, then I take k elements ahead, and then I can take the minimum of it, So I pop the minimum from the heap, and then walk one element that is now 3.
Yes.
Okay, then push an element that is 9 here. So then I take the minimum again, that is 1. Okay. All right, and push the 1 here, right? And the heap is always going to guarantee that. Actually, we are using a min heap, which always going to give us the minimum element. And that's pretty much it. And then I discussed about complexity, because if we had to use a sorting algorithm of Python, it will take n log n. But now since we are using just sorting a k range, this is going to be like log k times all of n. So it's going to be n log k, like the complexity. I kind of derived this on the while talking.
I see.
And that was pretty much it. And then the code was kind of fast.
Okay, that's fine. It seems like you kind of magically got to the solution, which is a little concerning. But I mean, you solved it and you were able to walk through it. So that part is fine. The problem I have right now is, where does this idea come from? This idea of, oh yeah, let's look ahead k number of elements and we pick the minimum. That's where I would have some concerns and reservations. Let's see, k.
Take the minimum.
All elements are at most k
Yeah.
elements.
They're at most k distance,
Okay.
k elements distance. So I took this as a fact, because they can be k minus one, k minus two. They can be like whatever in k range, whatever in any place in k range.
I see. Okay, so I understand. I understand why you made the logic. I think your explanation just kind of sucks, though. The reason why is because if you ask anyone else where this idea came from, and you just kind of, it just like it wouldn't make sense. But let me see if I can try to explain it. So, and here's the way I do it. And I'm going to explain why I'm harping on this. So, the array 3, 1, 2, 2 is k sorted with k equals 3 because each element in the array is at most x positions away from its sorted position, right? And so your function, the goal here is to create non-negative k with a k sorted and a k sorted element of array integers, which means that this array for any given element you are already given that it takes that it's already k distance away from its actual position. And so you need to return the sorted version of the array. So given that, you know that no matter what happens, the elements at any position will be at most k distance away from its real position. So with that, you can actually pull it within that range of k to where it's supposed to be. So the element in the first position, is k distance away from it. So you take the minimum at that position because the left-hand side must be minimum. And then you go to the next one, and so on and so forth. And you would walk forward. And you only have to look forward. You have to look backwards because you can reuse the previous elements that you've already seen. So I understand. So that's the way I would probably explain it. My explanation still kind of sucks, but you can kind of see like where the logic takes place. Does that make sense?
Yes, you didn't mention hash map.
No,
you didn't mention heap because you just explained the logic.
I explained the logic. I explained the core intuition behind it. So it's like the way it's like because I recognize that at any position, the element that is supposed to go there is at most k distance away. So all that are k distance away from that position, and I'm guaranteed that element that belongs is going to be in that range. So all I need to do is just traverse from left to right, and eliminate all the elements that are less than that. Because if I iterate from left to right and eliminate the elements that are less than, then all I have to do is just take the minimum in order to get the next element. So for instance, for 5, 3, 1, 2, 0, I know that I need to find the minimum element that I can possibly find because the element in the first position must be the smallest. And in which case, I'm guaranteed 0 is within that range. So I grab that. Then I need to find the element that belongs to position 1, which again, I just have to look at elements within k range of that, and since I've already used 0, the next greatest element, the next smallest element is 1, and then so on and so forth. So I didn't have to throw a hash map or anything at it. I just had to explain the intuition and then just like build on top of it. That's the difference. How I would do it.
Mm-hmm. With your explanation, I can see a better improvement for my answer.
Yeah.
Without using extra space, we can use like just the heap. I was using a X-ray array, but for this iteration, we can use like the current pointer that we are traversing, maybe. Yeah. Just to place the minimum element. Yeah, that will improve the memory.
We could do that. We could just like do a n log n insertion and do it in a tree ish. I mean, there's a room for debate. I think heap is fine, but you still run into the n log n time. But you notice there is obviously a way, if I thought a little bit more about it, for us to get faster than n log n. And that's the difference. Is that because I built it from the ground up from logic, whereas you kind of like magic bulleted it, and you kind of end up with a solution. Don't get me wrong, you came up with a solution, but it's just like because you didn't figure out the logic behind it. It's very difficult to improve upon it and get faster than the n log n. Does that make sense?
Even though I was trying to explain with what I was doing with the hash map, like with you think I had just to derive from the logic the use of the hash of the heap, right?
I think if you do that, then it becomes a lot better because it's clear where the idea comes from. But if you just do a magic bullet, then it's like I don't know where this idea comes from. I don't know how to improve on it. I don't know what makes this thing tick. it's like when you want to modify like say a clock or a computer, but you have no idea how a computer works.
Yeah,
So
I see.
I see. So that's kind of like where I see the problem is that you didn't really build the argument from the ground up. I mean, you got the answer, which is great, but it's also why the guy needed to give you the hint. But I mean, to be fair, I think for this one, I might have needed the hint actually, but then I would have just immediately done it like that after that.
Explain better than me. Yeah.
Yeah, that's probably the key difference. That would have make or break the interview because it's about being able to logically explain and walk through your answer at that point. And I mean, it's still something you need to work on, but it's like everyone needs to work on it. To be fair, so anyway,
Okay.
so I would give this like an average. Like it's like if you since you got the answer but with a hint, it's an average performance. I mean, you were able to at least test and say why the idea is right or wrong, but it's okay. I wouldn't say it's stellar, but I'm surprised the guy. I'm surprised the guy said that you were prepared. So you know.
Yeah, he also gonna be interviewed by Microsoft as well. So yeah.
Yeah. So for me, this is like a 5 out of 10 performance. It could be better. But
really average. Okay.
Yeah. It boils down to being able to explain it and to have that logic, there. So that's fine. Other than that, it's okay. Do you have another problem that you want to show me?
Just give me a minute.
Yeah. Yeah, so let me write that on your sheet.
Yeah, actually, there was, being honest here, there was no more problems where I struggled or yeah.
Okay. All right, that's fine. But it seems like you're able to do the what's it called? The problems with no problem. How did you verify that they were correct? Did you run it through like the compiler or?
I ran on the LeetCode compiler.
Okay.
So.
And yeah, they said you were good.
Yeah, like as I mentioned, like from all those problems, I think two or three of them, I had to verify my logic just to see where I did wrong because I haven't passed in all the test cases. So that was pretty much it.
Okay, that's fine. If that's the case, then which ones were they?
I should have took a note, right?
Yeah,
I will do
it. If you fuck up on something, like you should be.
Yeah. I should have
Yeah. So I mean, I sent you the example of like, oh yeah, look at how meticulous that Pavel was.
For sure. Like I was doing this until like the 10th.
Yeah. So it's like So you got to see like, yeah.
I started with. I think the cinema seat allocation. No, actually. Yeah, the sorted. Just a minute. Yeah, I think the first one here, like find any unique integer sum up to 0, was kind of obvious, but I didn't consider a edge case, which was pretty obvious.
Okay. So the question, if you didn't consider that edge case, you should be writing notes on that.
Yeah, you're right. Man, just a point here. Sorry, like my performance in terms of practice has decreased.
That's fine. I think you're busy with school, so you're distracted. So
yeah.
But notice notice you make the most improvements when you are super meticulous about your feedback.
Oh, for sure. You're right. So, you're right.
Yeah.
Okay. Yeah. I think I just have to say this. Like I was kind of very tired.
That's fine.
As well.
I get it.
But I'm gonna take meticulous note just as I was doing the test. Sorry about that.
Okay.
I just can't remember by the top of my mind which was the mistakes.
Okay. Fine.
Mm,
All right. And you don't have any other problems to show me?
no,
Okay.
unfortunately not.
Okay. So since we have time, let's do a quick interview problem,
Okay,
and then
cool.
hopefully this sinks in about the what's it called, the point about trying to explain things slowly and logically.
That's cool. That's cool.
Okay, let's do it. Let me pull up a sheet.
Hold up. You're going to
The problem sheet.
use
You
the
want me to
problem
link to you?
sheet. I think I have the link.
Cool.
Hold up.
Okay, let me pull up a problem.
I wish the interview was Monday, to be honest.
Yeah, but I mean, you schedule it. We had that Facebook thing, so obviously we weren't prepared for that. So we do what we can.
They gave me this date. I had no choice.
Mm-hmm.
They just give me like the choice of the hours, you know. Yeah.
Mm-hmm. Let's see.
So I'm on the problem sheet.
Yep, I know. I'm looking for a problem.
Mhm.
I'm trying to find one that I have not given you before, which is kind of hard. And you've already done a lot of problems, so it's like I might have to pull a harder one out.
Oh man. Okay.
Let's
That's
see.
good. A harder one.
Maybe this one. Do I want to get this one? Let's see. No, this is easy. I think this is easy. The heck is this? No, this is easy. Screw it. No. Yeah, this looks like it's way too easy. Hold up.
You can take like from the problem sheet maybe.
Yeah, I know. Chances are you probably don't remember every single problem anyway. So
Yeah.
I'm trying to pull up my. Oh God, I have so many documents here. I'm trying to find my master sheet.
I can highlight the ones that I never did before, if you want to.
That's fine.
From the
I have my own
actually.
sheet. I have my own sheet, and each problem tests something different. So I'm pretty deliberate about it.
Oh, good.
Not this one. No. Okay, let's see. I think this. Yeah. Okay, got it. Found the sheet. Let's see.
You probably have a database of questions
I have
sorted
this
by
thing is
level, right?
163 pages. So yes, I do. I'm just trying to figure out which problem is the best one to give right now. No, valid string. I'm sure you've seen this one before. Let's see. No. Okay, given an array of positive integers, consider all binary trees. Yeah. Okay. All possible binary trees. Have you seen this one?
No.
Okay, cool. So then this one should be good. I think it might be a little bit on the easier side, but we'll see.
If I remember by the description, I will tell you.
Given an array of positive integers, consider all binary trees such that each node has 0 or 2 children. The value of the array corresponds to the value of the leaf in order traversal. Does that ring a bell?
The value? No.
All right, cool. All right, cool. So then let's do this problem then.
All the possible binary trees. Okay.
Yeah. So let me start the timer. Let's do this. All right. So here's the problem. Given an array of positive integers, I want you to consider all the binary trees such that 1, each node has either 0 or 2 children.
Mm-hmm.
Second one, the values of the array correspond to the values of each leaf in an in-order traversal of the tree. Recall that a node is a leaf if it has only 0 children, right? And the third one, the value of each non-leaf node is equal to the product of the largest leaf value in its left and right subtree, respectively. Amongst all possible binary trees considered, return the smallest possible sum of the values of each non-leaf node. So, what? So this is a little bit complicated. So let's go through an example, right? So first one, suppose that I gave you an input array of 6, 2, and 4. The output of this would be 32 because there are two possible trees. The first has a non-leaf node sum 36, and the second has a non-leaf node sum of 32. What the heck does that mean, right? So let's look at this. So you have 6, 2, and 4. So if you look at this, the non-leaf sum. Oh, excuse me. Sorry, a small headache. So the array here, 6, 2, and 4. Does it? Actually, wait, shit. Did I fuck up on the example here? Hold up. Let me make sure that I copy the right one. Wait, no, not this. Wait, sorry. I fucked up. Not this problem. I realized that that the answer for this is actually gonna be way too complicated. It's for what I'm trying to test. Sorry. Little reset.
No worries.
Yeah, I fucked up. I gave you the wrong problem. This is not the right problem I want to do. By the way, but that is a LeetCode problem. I would recommend people try it.
Is it a medium or hard?
I think it's a medium. I think it's a hard because it's at the bottom of the sheet. So that's a hard.
I imagine.
Yeah, that's not the not the right one. No, not this one. Oh wait, this is just Huffman encoding. I think you've already studied that, right?
What?
You studied Huffman encoding in school?
It's familiar. The name is familiar.
Yeah, so this problem is just a Huffman encoding. Not this one. This one's file system related.
I guess to discover bits that are invalid or something.
Yeah, something like that. Sorry, this is gonna take me a while to find the right one.
No worries, take your time.
Minimum number of invalid parentheses in order to make the input string valid. I think have you seen that one?
Yeah, that one is studied.
Yeah, that one you've already studied, so I can't give you that one.
And you also gave me like a very, very detailed approach to this one.
Okay, yeah. Given a non-negative integer num represented as a string, remove k digits from the number so that the new number is as small as possible. This one might be easy, but let's see if you can do it. This one should be...
No, it's not familiar.
Okay, this one is pretty easy, I think, but it should be very... your explanation should be very simple and logical. I think this one's pretty easy. So so I'm focused right now on the explanation and your logic behind the problem. So, okay, let's do this one.
Good.
All right. So given a non-negative integer number represented as a string, remove k digits from the number such that the new number is the smallest possible. So, for instance, if I take this number 1432219, I want you to, the output here would be 1219 for a value of k3. Why is this? Because if we took out three numbers here, the 4, the 3, 2, then we end up with 1219, which is the smallest possible number that this can be. Does that make sense?
Totally.
Okay, cool.
Yeah, just one question. Like the numbers, they can be sequentially, like they need to be sequentially. They need to be 4, 3, and 2, or they can be 4, 1, and 9.
It could be any number. This is just happens to be in descending order, but this could be random as fuck. Got it?
Good. Sounds good. Well, let me break a page here.
Okay.
Oh yeah, I'm on mic. Okay. So the first thing I'm thinking is basically try all the possibilities by removing k elements. Okay. So I'm maybe gonna try to remove all the possible combinations of k. So for example, let me check here. Oh, again. So for instance, I'm going to try actually just like, I'm going to not put the quotes just for a matter of simplicity. So I'll try from the first one, like that is this number.
Uh-huh.
I know that I can delete 3 elements. So one thing I'm gonna do is delete the first 3 elements, right?
Okay,
So
why
at
would you delete
this
the first three
first,
elements?
uh,
Where's this idea
at
coming from?
every, okay, at every iteration,
Mhm.
I'll just go into, mm, yeah, yeah, that's the point. I'll go into delete. Actually, I'll take the current index I'm at, so I'm gonna be in 0 at index 0 here, and yeah, but actually I should mark. But just a minute here. Okay, so I'll go into take this first one and delete, and just substitute with the asterisk to mark that is deleted.
Sure.
And try to delete those 3 first. And then check this number, 2,209. Okay, and then yeah, I can store this.
Okay.
Just have a array of numbers I can form.
Sure.
And then for other possibility, I can like have go back this 3 here, and delete this one. Yep. So I'll have 3,000, So yeah, that way I would try to generate all the possibilities by just invalidating the character. So 219.
Okay.
That's a way that I'm just thinking. So the asterisks are gonna mark the elements that are gonna be invalid. And imagine that this asterisk is in the end of a string. What I'm gonna then do is try all the possibilities for moving the second asterisk.
Okay.
So for example, this first one starting from here, and like now the second one is gonna start from here.
Okay.
And yeah, the third one is gonna start by here. Okay. So I'll have 4,219. And yeah, just basically this.
Okay. So basically, you're just trying every
okay.
single possible combination of deletions that you can get.
Yeah, that's right.
Okay.
And yeah, actually, instead of store all my possibilities, which is gonna have gonna cost a lot of memory, I can just traverse over the string, just to form the number, and compare with the greater number that I just have in a variable.
Okay. Sure.
So I can always compare with a max value.
Okay, that's fine. You're just gonna compare with the maximum value and then keep the minimum. That's fine. But what's the runtime of this algorithm that you got going?
Yeah, let me think here. Well, actually, since we have to try all of the combinations of deletions inside of array, inside of a given array, okay. It's going to be O to the power of, let me think. It's a combination inside of element like this. So it's no, I'm not gonna guess.
You walk through step by step.
Yeah, I walk through step by step. Oh yeah, actually, so let me go back and try just one thing here. So imagine I first try. Yes. Okay. So imagine if it was like a nested for loop here. If it was 2 nested for loops and squared, if it was 3 for loops and to the power of third, and since it's like K is going to define the level of kind of nested operations we need to do. It's going to be n to the power of k, if that's correct. Because as I mentioned, if it was 2, is analogous to a nested for loop, and so on. If it was 3, 3 nested for loop. So all of n to the power of k will be the time complexity for this. And actually, in terms of space complexity, all right, this I was wondering, I was thinking maybe to use a recursion algorithm here.
Okay.
We're not gonna have n to the power of k elements in the memory. We're just gonna have a range of possibilities. So for this, it's going to be the height of the tree of possibilities, which is hold up. Yeah, like I just need to define this pretty clear. It's like that is all the possibilities. Yeah, actually I can just delete k. So is all of k. That is going to define the height of the tree, because I just need to try k possibilities, like k deletions from the array.
Okay.
So that's going to be the time complexity.
So your runtime is order k, n to k, and then your space is order what?
Order k, all of k.
I thought you said you're just gonna compare the minimum that you've already seen. So.
No. That was my first idea, just to store in an array. But I'm not gonna do this. I actually gonna use a variable. So there's no need to store all of the elements I just created.
Okay.
So I'm just gonna pass a variable and to the recursion.
Okay, so k just represents the number of digits.
Yep.
Okay.
That's gonna be the height of our tree, of our recursion tree.
Not really. Okay, sure. We'll discuss more about that, but yeah. Okay, I get where you're coming from. All right. So obviously this is kind of a shit time. So what can we do to do better?
Maybe I can think about, for example, like given the fact that, for example, at this example here, right? Given the fact that when like those 2 deletions happen and this last one happen, right? If I have to increment in the second example here, at some point I'll have to delete the last one, right? So as we can see, there's going to be a repeated operation here. So maybe I can try to avoid those repeated operations, but I'm not sure how to do this. Actually, if we avoid how to do those repeated operations, we can, I'm pretty sure we can decrease the time complexity for something around all of n, right? So by just trying all the possibilities, kind of just moving the deletions, inside of here.
Okay, so you want to optimize the deletions and skip some. So how would you do that?
Yeah, that's the point I'm thinking. Okay. My logic's not so clear, but I was just gonna draw like a possibility here, like just to see where I can go.
Sure.
So, for example, just to see where I can kind of do a memoize solution, or maybe even more simple solution. So yeah, so for this, I'm gonna delete this first one. Delete the second one. Yeah, at this point, there's nothing else for me to do here. Yeah. Okay, so yeah, it's pretty much what I will do. And for a second branch, it's going to be something like, instead of the third one, I'll try this element here.
Okay. Well, the thing is that how is this fundamentally different than what you are have you proposed with the naive solution?
No, I'm just doing the naive solution here, just
Okay.
to see where I can do better,
Okay, fair.
and reutilize the states.
Sure, sure. So you want to go down
So
the dynamic programming route, okay?
yeah, I don't know if it's that adequate, but anyways, um, okay, so mm, yeah, actually, the states that are changing are like the positions in which I'm deleting,
Mm-hmm.
like the elements. So, for example, this is the index 0, 1, and 3. Um, mm, but this is going to be different for every iteration, so I cannot use this fact. Like looking for the local changes. For example, those first two deletions here, they're not going to change. It's only this last one,
Yeah.
right? And like one thing. mm, Yeah, because for example, I was thinking if I have a deletion happen here,
Yes.
and imagine that this element is something like this.
Mm-hmm.
By storing this state, this specific state for just one deletion,
Yep.
it's not gonna help me,
Okay.
because in other iterations, it's gonna be different numbers that I can form. So I think that's not a good route.
Okay. That's fair.
Let me just think if there's anything else, anything better I can do here. So yeah, given this, I can try all the possibles. Yeah, by trying all the deletions as like try one deletion after the other, but one minute here. Wondering maybe yeah, since this k can vary, can be like greater than 3.
Mm-hmm.
There's no way, there's no better way. Like I can change all the, I can do all the combinations without like without considering something. Let me just check one thing here. Okay, I'm just trying to see where I can reuse my states. The states.
Well, you've already said that you can't reuse the states because this is every single possible combination. You can't reuse this because once we what's it called? Once we arrive at this state, there's no reuse for this necessarily, unless you think there is one. But
I was just wondering if there is anything else I didn't explore.
Okay.
In that sense.
Okay.
Yeah, like for example, yeah. Okay, 1 4 3 2 2 1 9. Yep. Yeah, actually, are going to be pretty different numbers.
Okay.
And we have states that overlaps here. There's no use here. So I'm just wondering, in like this dynamic programming, if there's anything else I can do here.
Okay.
the length of the number is less than 10,002, and the given does not contain any leading zeros. All right. Yeah, I guess I cannot see like a clear way. How can I reuse states here?
Okay. So you can't reuse the states.
Huh?
Okay, so you can't reuse the states. So then but you can get faster, so.
How can I get faster? Let me think here. The new number is the smallest as possible. Even represent a string, remove k digits from the number so that the new number is the smallest as possible. So yeah, like actually we are looking for the minimum, not the max, was the thing that I just said in the beginning. But using like that approach is gonna be used for the minimum as well, right? Because instead of the max, we can just verify using the minimum for each iteration. And going back to the reuse state problem, we maybe we can use some condition on the array. So for example, I know that when starting with 1, maybe, and I have 3 deletions, right?
Okay.
So if I start my deletion from here, I know that maybe my first number, the number of the remaining element, I'm just trying to see if I can use this fact. Because for example, if I have like this, 1043 here, and like comparing to other ones I can delete.
Okay.
It's going to be 2000 starting with 2, or any other number in between. So maybe if I use this fact of like the first number, always be smaller, always try to be smaller, like in the following numbers, always be the smallest. So yeah, let me just try one last approach here.
Okay.
So for example, if I have, k is equal to 3. So one thing that I'm thinking is to take the length of the array, that is 6, 7. And then I'll have 4 digits I can have.
Okay.
So
wait, what do you mean 4 digits that you can have? Because you have length 7. Okay, so you have 4 digits.
Yeah, for the output. Yeah.
Okay.
For the output. So one thing I can do is basically try to make a combination of those 4 digits of this array, that they must be sequentially, I cannot change the order.
Sure.
So yeah, I'm just inverting the problem. Actually, instead of deleting, taking 4 digits.
Okay.
I think it's gonna be in the same place.
Okay.
And take 4 digits that forms the smallest number. That's another approach, but then then actually when I try other combinations, for example, here I'll try those. Let me put asterisks here. Okay, so I'll try those first 4 digits, and then I'll try those, like just the same logic, but now taking the elements. But then when I try like other solution, try other combinations of 4 digits, one thing is for sure: if the first digit starts with if the first digit is greater than like the minimum I already visited or calculated, that's not a valid chance. So, for example, when I start all the possibilities by 4, I can kind of prune my tree of possibilities,
Okay. Yes.
And when starting by 3,
Mm-hmm.
I can prune because there's nothing else. There's nothing smaller I can have
What do
starting
you mean
from
by
3.
nothing smaller? I don't understand.
For example, if I start if I start with 1, right?
Yes.
Starting with 1, the smallest possibility is going to be 1, 2 is going to be the result, like 1219.
Okay.
Okay.
So that's if you remove 4 elements. Okay. Sure.
Yeah.
So then.
And but then if I started from any other number here ahead of it of 1, I cannot have a smaller number. So for example, even if I started with 4, all the remaining elements
Sure.
are going to be 4,000 or something,
Okay.
or 3,000 or something, or 2,000 or something.
Okay. So you
So
just picked whatever numbers to delete. Okay.
yeah,
So then, how do you decide which numbers to delete?
I'm going to decide the numbers to delete. Uh, Comparing, actually taking the numbers I selected to be like the smallest, the
So you
indexes
selected
of
one
them.
to be the smallest. You're gonna delete one.
Can you repeat?
You said you're gonna take the smallest number and delete it.
No, no, I didn't say that. I said that I'll take the smallest number just to consider the smallest,
Okay.
but
But how do you
for
know
the
it's the
index,
smallest to begin with? Because that's the whole point of
I'm
the
gonna
problem, right? You want to find. You're given 1432219, and you want to get out the smallest number.
I'll try to build
Okay.
like the smallest number in all of the iterations,
Okay.
So instead of delete, I just mentioned our k is equal to 4, right?
Okay.
Then, based on the length of the array, there's like our k is equal to 3 here.
Okay.
Based on the length of the array, the remaining elements are 4,
So
So
you're gonna
I'll
pick four
try to
digits. Okay.
choose 4 digits that forms like my smallest element.
Okay.
That's where I was trying to go.
Sure, but that's what the problem's asking.
Yeah, and then at every iteration, I'm gonna check if it's smaller or not. So that's what I'm gonna do.
Okay.
So I can walk through
Yeah, go walk through an example. I have no idea what
decision
you're talking about. So.
tree. Okay, so for example, here, okay, just doing the same thing. So at this first iteration, I'm just gonna take the first one here.
Okay.
At the second iteration, I'm gonna take those 2 here,
Okay.
and so on, like 3 and 4
Sure.
for elements. Okay, so at this possibility here, I have like the smallest element with taking 4 elements,
Okay.
It's 1, 3, 2, Okay, then I'll try the second possibility.
Sure. Okay, I know where we're going with this, but my question now is how's the runtime different than deleting? All you've done is instead of deleting, you just added.
As I mentioned before, like it's more intuitive to me here to prune my possibilities. So,
Okay.
So for example, imagine that I completed all the possibilities starting from 1, 1, 4, and I tried all the remaining possibilities.
Okay.
And I eventually found this one that is the result.
Sure.
I'll try to like perform other possibilities based on the second element, starting from the second element, So that starts with 4. But then I would realize that I cannot have like any four digit elements, uh, four figures number that can form like a greater number. Because, for example, any number ahead of it will start with 4, so all of the numbers ahead is going to be 4,000 or something.
Okay.
4,000 something,
Sure.
4,300, 4,200 and something.
Okay.
And that's the possibilities we have here.
Sure, but the thing is that like you said, you only can get to that state if you discover this number 1219.
Exactly.
Okay, so which means that you still need to traverse every single possible digit to add.
But you're right. But if I manage to find the smallest one,
Okay.
I'm just gonna prune this possibility and not gonna try because it's starting at 4. So imagine that here instead of 1,200, I found 2,000.
Sure.
And imagine that the second one is like 1 as well. So I would try this possibility because imagine that this first one starts with 2 and this one, it's going to be a copy of this. So there I can have a smaller possibility, because it's starting with 1. That is smaller than this first element here. That's what I was trying to say,
Okay, but how would you discover 2219 to begin with? That's the part I don't understand, and how it doesn't help you beat your runtime. I mean, even if you prune parts of the tree, that's just an optimization on the existing runtime, no?
Yeah, that's the optimization I was thinking about.
Right,
like just prune based on the possibilities I already found.
The exact same problem. How do you get to 2219 to begin with in a runtime that is not order NK?
And the worst case, it's gonna remain the same runtime.
Even
You're
in
right.
the average case, it's still gonna remain the same case. So yeah.
No, but like in the average.
If it's average case, then then show me that. I don't understand where you're getting better than order NK, but why don't you do it on this example and show it to me?
Okay, so starting here. Okay, so for example, I'll try those first 4 elements.
Sure, you're gonna add the first 4 elements. Okay.
Yep. Yeah, it's incrementally.
Okay.
So, yeah.
I get it.
And at this point, I have, and then here's starting from 7. Okay, so starting from 2, the smallest element we can have here is like, let me just see, 2,119 is the smallest one.
But you only discovered 2132 so far. That's the smallest one you've discovered.
I'm okay. I'm gonna do all the possibilities. You want me to do this? I will do.
I don't know. I'm just following your example, dude.
Okay. So, yeah, let me go to the second one. No, actually, I'm gonna do all of them. Yeah. Then, this one, and I'll have the other element here, the other example.
Okay.
Then I'll go on the other branch and try all the other 4 possibilities,
Okay.
So instead of jump to this one.
Okay.
It's another 2. Actually, it's the 1.
Okay.
I meant.
I get it. So yeah, now you're up to 2131.
Yeah.
Now what?
And then I'll try the other possibilities for the upper element.
Sure.
So, yeah.
So I get where you're trying to go, but again, it doesn't. I know what you're trying to do, and I'm telling you it's not going to work because what you're basically describing is 2219. Eventually, you're going to get to a point where you're going to add 2, 3, blah blah blah, whatever at the end.
Yes.
I know what you're trying to do, and I'm trying to tell you it's not going to work because all you're doing is just pruning some branches, But fundamentally, you're still going to get order nk time. It's just a faster version of nk time, but it's still nk.
Okay,
And it's
so I can
and
change
it is
direction.
predicated on finding this to begin with.
You're right. So I can change directions then.
Right. That's what I've been trying to tell you for the past 10, 15 minutes.
Okay. Let me think. Maybe recursion is not the best approach here. So yes, like going into this idea of I just need to take 4 elements to form my final element. 4 characters to form my final output.
Okay.
So like the thing that is most obvious to me is to just try to take the smallest elements I can find along the way. So I'll try like 1 is 1 smaller than 4, yes. Let me put a better example here.
Okay.
Like, yeah, oh, nice. I think that's a good one.
Okay.
Like, no, but I'll do one traversal here just to find like the smallest one, you know. Then, yeah, I'm just gonna use that one. But then I was just trying to, there's 2 ones. I can use this one or this one.
Okay.
But maybe I use this one because there's like k elements ahead that I can use. So yeah, I just use the one. And then I'll try to visit the ones ahead of it, you know.
Okay.
Then like to take the smallest one. So imagine that the k was 3, and then now k is 2, right? So I need to take k elements. No, actually 1 element that has two elements ahead of it at least, you know, the minimum. So I would take actually k was 3, you know, but the remaining k is the elements that I can delete. Actually, the number of digits is 4.
Okay.
And now is 3. All right. So so same thing here. So the minimum element that I can find that still have like counting from the element 3 more elements ahead of it is this one, that is 2. Okay, and then from 2, this 3 is 2. Yeah, like the smallest element I can take is 1, and then 19. Yeah.
Okay.
So basically, the general idea here is going to be divided in steps, right?
Okay.
I'll take the k, right, and the length of the string, and take the difference of it, because that difference is going to be the length of the minimum number I can find.
Sure.
Then what I'll try to do is, by traversing this array, okay, I'll just going to try to apply this rule set of find 1 element, right, that still have this number of digits variable that I just put here.
Sure.
Ahead of it, the minimum number, you know. So in this example is the 1.
Okay.
Right? And then I'm just gonna decrement this number of digits, and just try the sequence. Like I'm just gonna try to find the other element that is the smallest one, but still have number of digits ahead of it, decrement it. So that's basically the rule set of the algorithm, the logic of the algorithm I was thinking to implement. And this is going to run in all of n time, because we just need one traversal into this array.
Okay, so basically you're gonna pick you're gonna pick the number of digits where you have one digit and that has 4 digits ahead of it, or at least 4 digits ahead of it?
No, including the digits, the number of digits I have.
Okay.
So actually, yeah, I can use the number of digits minus 1 just to be more.
Okay, so you're gonna
more simple. Yeah.
So
the number
through the array, and then pick a number that is the smallest number with number of with at least n number of digits ahead of it, which is the number of digits here. Then you decrement the number of digits. Then you find the next smallest with at least digits ahead of it.
Yeah, from the one I just chose.
So then why didn't you pick 1 here then?
Why don't you pick what?
1.
Because the 1. Because 1, I'm just gonna have 1 digit ahead of it. Okay. I need to have 2 digits ahead of it.
Okay, so what if I added another 9 here?
Okay, if I add another 9, let's see how that goes.
Yeah.
I will try to look for the smallest. So let's just try to see the algorithm here.
Okay, so you had found 2 1s. That's fine.
I think your cursor is blocking.
I got it.
See?
I got it out already.
All right. So yeah, I'll take the smallest one, right? The first one that is smallest, which have 3 digits ahead of it at least. Then it's the first one here,
Okay.
Then I need to have, I'll decrement this. I need to have actually now 2 digits ahead of it.
Okay.
So doing the same thing here from this one. Then, yeah, I'll take the 1 here.
Okay.
Yes, there's a problem. And from this, you just break my logic. Yeah. This is going to decrement, and that's going to be 9. And that's not the smallest one.
Okay.
You're right. And then I'll try the other.
Okay.
Which is not the smallest, because we can have here like. No, I took the 1. The 1 here. That is this one, and then those 2 9s here. That is 199, which is the smallest we can form here with 4 digits. That's basically this.
Okay. Let's see.
I can test with another example.
Yeah, like I'm trying to see it. I mean, I understand where you're going with this. I understand why, but. I would definitely want to try with another. I get that you're trying to get the smallest number from each one.
Ahead of the last one I pick.
Yeah. So how about this? What if I tried? Actually, I oh huh. Does that? I think that okay. Yeah. Let's try another example. But I understand where you're going with this. I'm gonna try. Let's see. Try breaking it. Let me think through this.
Yeah, okay, let me just try to generate one example. So 3, 2, 1, 6. No, it's pretty easy. So 1, 2, 3, 4. Yeah, and imagine that we can delete here 3 elements, right? It's 123. It's going to be the smallest, right? So is it okay if I try this one?
Yeah, go ahead.
Yeah, so imagine that k is equal to 3, right? So the remaining elements yeah, the number of digits is going to be um, actually 3, all right? But I'm just going to decrement 1 because we're going to start from this one.
Mm-hmm.
So what I'm going to do is actually traverse this entire string here,
Mm-hmm.
and having the, like, starting the smallest one, that is 1,
Mm-hmm.
right? Okay, then this one is marked like as my starting point. Then again, like in this one, I'll try all the other elements ahead of it. Then pick the smallest one, that is 2, you know.
Mm-hmm.
And now this is decrementing. Yeah. And then from this 2 here, yeah, I'm just going to do the same, you know, just take the smallest one, that is 3. There's nothing else for me to try here because this is going to be 0, and yeah.
Okay.
Okay.
So, okay, I see what you're going with this. I think there might be an answer that. Okay, here's
It's less complex.
no, there's a I think there's an example that might break it.
Okay, go ahead.
What if I gave you this number?
Let's try.
Yeah.
Okay. Do you have a K of preference?
Let's do K of 3.
Great. So 3, it's going to be like remaining elements is going to be 2 because it's remaining minus 1.
Okay.
And then K is equal to 3, as you mentioned.
Yeah. So we'll remove 3 elements from this.
Yeah. Actually, K is equal to 3, right?
Yeah, K is equal to 3, correct.
Great. So, but I'm starting this number of digits with 2 because at the first iteration, I'm kind of just going to decrement.
Sure.
Yeah. So yeah, imagine it's 3, and then at the first iteration, you're going to decrement here. And like what I'm going to do is traverse this and take the minimum. That is 1. That's going to be the first one because the second one I'm not allowed to take because there's not a window of 2 ahead of it, you know. So I'll just stop looking on the 4. So yeah, then I'll consider this one. Then starting from this one here. So just gonna mark as a starting position. Actually, just correcting the time complexity, right? It's not gonna be all of them because we're just gonna have to do multiple traversals just to. I can work on that actually later.
Okay.
And then yeah, I'll just go and decrement this one here. And yeah, I can take the 3, you know, because there's 1 element ahead of it.
Okay.
And then 0.
Mm-hmm.
Like I can choose a third element which has like 0 distance from the end.
Okay.
Then I'll take the 1.
Okay, I think this works. So I'm very curious how you're going to write the code for this.
Yes. Okay, I can. Is it okay if I do it now?
Yeah, go ahead.
All right, so just going to write down here to be more close to the actual idea.
Sure, let's see how you do
So, like, find min. Actually, yeah. Delete k to find min.
Mm-hmm.
Then we're gonna receive k and the array as an input, and just to guarantee here is an edge case. Yeah, the length will be num is less than 102, and it will be yeah, it will be greater than k. So I'm assuming that we're not gonna have numbers. We're not gonna have k's greater than the length of the array. Is that correct?
We're not gonna have a number. You can assume valid forms of k. Yeah, so you'll assume that k is gonna be less than the array length. Sure.
Great. So I'm not gonna validate this as well. Okay, so the other thing I'm just gonna cover here is that the array actually is not an array. It's going to be a string, as you mentioned, right? Just correct fixing here. And is there a case where I can receive an empty string?
Is there a case where you can receive an empty string? If you do receive an empty string, well, your code should be elegant enough to handle it, but yeah, you might.
Oh, okay. I'm gonna consider as 0 because empty string we cannot form nothing, right?
Sure.
So yeah, if length of the string is equal to 0, I just return 0. And another edge case here is that maybe k is equal to 0. Okay, so I'm just gonna return like the string itself because it's actually a string, because there's nothing I can delete, so the minimal number is going to be the actual string. So if k is equal to 0, I'm just going to return the string itself. And let me see if there's any other edge case I'm not covering. Yeah, okay. So, okay, good. I think those are the edge cases.
Okay.
And now the current code.
Sure.
So just to be easier to convert, I'm just going to actually, oh yeah, there's no need because we're gonna have to do a traversal. Yeah, actually, I'm gonna iterate through this array. So one thing here, like I'm just gonna have a variable to hold the result, that which is gonna be a empty string, and then 4 element in the range of in the string actually. No, actually, if I use a 4, it's not gonna work because we might skip elements. So I'm gonna have this variable called index equal to 0, starting with the 0, and then while index is smaller than the length of string minus 1. Yeah. I just need to repeatedly do this traversal here. So like at every element, I need to check the ones ahead of it. So like I'm going to do like number of digits. That is the number of digits my string can have. It's going to be k minus the length of, no, actually length of the string minus k. And yeah, and number of digits minus 1, I'll decrement it, and then for j in range of index up until like the length of a string minus number of digits.
Okay.
I'm just going to take the minimum of it, so like I can have a min element here.
Okay.
Which is going to start with this infinity. Okay, max infinity. And then if string j is smaller than the min element, what I'm going to do is just substitute. Yeah, actually, there's a faster way to do this. Just take the minimum. There's a min between this and this. And yeah, what else? Okay.
All right. I'm gonna pull the plug, just for the sake of time. But
Good.
I'm gonna say that you did get to an answer. I'm not sure if your code will work, but I kind of wanted to discuss your approach. Actually, there was a few things that really came up I think are worth talking about. So,
Great.
I'll post you a link to the answer. That there's many ways of doing this one actually, but I'll point you to one that I think most people end up getting or something to that extent.
Okay.
And so yeah, when you're done with this one, compare it to the answer. But let's see. So first things first. Your explanations kind of need work for runtime. I mean, I think it's good that you got to the answer, but I think the biggest one was that you didn't really go step by step through your derivation. So for instance, that tree thing you came up with, and you kind of just like roll it off the end of the cake, but you didn't really work through how it came out. So you remember how you said, oh yeah, try every single possible combination of deletions? The thing is
Yes,
that
I
NK
remember.
times, it kind of seemed to come out of nowhere. So if you look here, and so I'm like, okay, NK, I get I get like why you said it, but I would rather you derive it. So the thing is that the way I think the best way to explain it is that you have a k number of loops that iterate through n minus k digits. Or yeah, that's the best way to describe it.
K number of loops.
You have
That's
k
a
number
keyword.
because you have one a deletion at one digit, and then the next that can iterate through 0 to n minus k, and then the second loop has to be one digit ahead of that previous one, right? And that can go to from 1 to n minus k minus 1 plus 1, and then so on and so forth. That's where you get the n minus k times n minus k times. Does that make sense?
Oh, yeah. The recurrence relation.
It's not recurrence. It's just nested loops. That's it. And so this is where like you need to be able to state that where your derivation comes from, and the fact that you kind of just like did it off the cuff was a little dangerous. But that's not. I think that's one of the big ones, and it's a common theme that I keep seeing today. So I would be very very careful. I want you to be able to state step by step how you arrived at your answer.
And when is the right time to derive like the complexity?
When it's not immediately
like
obvious.
as. Oh, okay.
Because if it's like you can't do it off the top of your head and like it's not blindingly obvious, then that's when you need to do it. And so this is where if you can do what I did, just explain step by step, it becomes easy, right? I remember you struggled actually quite a bit for this, for 2-3 minutes, and all I did was just state, okay, I know I'm going to do these number of steps, and I know that within these steps, this is the order runtime. And so you kind of see, I got there in a short amount of time just simply by walking through what your solution was. I think, but there's another point here. I basically told you after when you found out about the reuse states, right? You kind of figured out, okay, well, I can't really reuse it, and you spent another 5 minutes trying to force it, which is okay, that's a little strange. And then you kept spending, and you spent another 10-15 minutes trying to force your way to reuse the tree problem. So instead of doing deletion, you did the add with the prune. But I kept trying to tell you, pruning is not going to fundamentally change the runtime. Because all you're doing is just, you're cutting off some tree branches, but it's not systematic enough. Like you said, in the worst case scenario, you're still running order NK.
Yeah.
So I literally kept telling you this over and over again. You just kept going with it. So to me, I know why you're doing it, but if an interviewer saw that, he would just literally say, well, that actually increased the risk profile, because if you don't get the answer, then when we go in the back room and discuss, are you coachable? Do we want to give this guy a chance? The fact that you completely ignore me for two of these things would basically say,
it's a concern.
Hey, this guy's not. It's a big red flag, because this guy's not coachable. He's not getting my help. That would be an extremely big flag. So if you're doing that, if you're going to be very bullheaded about it, you better get the right answer. So you better see something the interviewer doesn't see. And 9 times out of 10, the interviewer is just there to help you, saying, hey, yeah, don't go down this route. This is probably not the right way. You should probably listen to him. and as
And
the host,
just conceal my approach.
yeah,
So at the moment you said to me, okay, you're not systematically going to change the complexity. I just had to stop and start over.
yeah,
Is
reevaluate where
that
you're
correct?
going with this. Like, I get you're trying. I get that it kind of helped you figure out this with the greedy solution that you came up with, but to me, it's like there's probably better ways of doing it. Um, I understand why how it fed into you solving the problem, but in a real interview, it's just gonna seem like a pretty bad red flag. And at the end of the day, it actually cost you 17 minutes of the interview as well.
Yeah, just trying a
Yeah.
solution. Yeah.
So you did come up with the greedy solution to this. There's other versions of this involving a stack. And I think if you look in the chat, Mr. Mystics actually came up with the stack solution, but it's not fundamentally different than what you just did. What you did is basically just you did a greedy one because like all you're doing is just taking the number of um, the digit with
Mhm.
oh yeah, it needs to be x or k number away from the end, which is fine. Yeah, I understand why this works. And then you don't and then but the question is, well, what happens if it's not k number? And this is where like I think your code might not actually work because you did consider all the possible cases in which the code doesn't work. And I think again, it's kind of similar to what we talked about last time, where if you actually just skipped, if you actually were like had the 17 minutes, I think you could have spent like 8 of it trying to test your code. And so this is why I think that your code will not work, but you're welcome to try for homework. And if you give up, the answer's right here. So the biggest one is just really not taking instruction and just kind of like jumping, like not really going systematically through your thoughts. But other than that, at least you got to an answer. And if you can code it right, I think all's good in the world. But so that's my feedback to you.
Okay.
I want you to be very careful about being very bullheaded about committing to your solutions.
Okay.
So, yeah. Anyway, are there any? I think one more other thing. The fact is that you kind of just kept going with the solution. What I would have done is I would have tried multiple examples. Once you realized, hey, this doesn't fit any pattern, this doesn't fit anything I've seen before, I would have gone through like just a bunch of examples, like literally random examples to try and look for a pattern. In this case, the biggest pattern that came to me would have been this descending order. It's like, wait, this is a descending order. I would have tried playing around this. Like what happens
Oh, I
if
see.
like what if happens if I tried 4 3 like 9 8 7 6 5 4 5
Mhm.
4 3 2 1? That would have been like I noticed this is like the first thing I would have noticed and just like okay why are we removing descending order, and I would have just tried testing. Oh yeah, k equals 1, k equals 2, k equals 3. Okay, we're gonna take all these numbers. Okay, so we know like in this particular case this will be the rule. Now is there other rules that I can do other shit with?
Okay. So maybe if I should have gave up on my idea sooner, maybe I would have more time just to try like a more optimal solution. Is that correct?
Yeah, that's basically the biggest one. After that, it would have been try different examples and look for like, hey, ascending order. Wait, this is kind of strange. What can I do about that? And maybe you would or would not have gotten to your solution, but this is at least something you could play around, and it's like it might give you more hints into the solution rather than trying to chase a dead end. So, like in this case,
Yeah.
all I did here was like, hey, this is strange. Why is there's a descending order? Can I play around that? And I realized, oh, wait a minute. If k equals 1 2 3 4, I just build from the right hand side, and if it's ascending order, then I know I just build from the left hand side. And that might have helped you with getting the answer as well. Yeah. So
I see.
yeah. So in this case, you delete from left side, right side. And it's like okay, now like what after that? I would try doing some mishmash combination of this. So this is like it's like knowing, it's just like seeing, hey, wait, this is kind of strange. This is like a pattern that I've seen before, and then just trying to work off that.
To get a better. Yeah.
Right. Instead of trying to like ram your head, you've already gone down the route of okay, you already know that going for the tree is probably not the right answer. And adding things, you're still doing the tree thing, and it's still going to get you order and k. And the interviewer's already told you that. And so it doesn't. So you can't go down the dynamic programming route because there's no memorization. There's not a very obvious solution. So now the only thing left is to try a bunch of examples and try to come up with your own solution. So.
Yeah, I see. It's clear as water. Yeah.
So it's just like like I'm not gonna harp too much on it. I don't want to make you feel too bad before this interview, but it's like just keep that example thing in the back in the pocket. Don't be so bullheaded about like, oh yeah, has to work. This has to work. It's like be a little bit more flexible and just say, hey, I don't think this is gonna work. And I would say eight times out of 10, the interviewer will probably tell you, hey, yeah, it's probably not the right route. But you at least came up with a naive solution. But it's about being a little bit more flexible with your toolkit. I know you're very used to iterating over and over again until you find the example, but sometimes there's no pattern. Sometimes it's just straight up you're on the wrong path to begin with the naive solution. I mean, you at least got an answer.
And yeah, I'm just remembering here. Like I just ignore you like on the first tree approach, right? Or like to delete.
Mm-hmm.
Yeah, and then I just kept on this idea of like adding numbers, and yeah, it was the same complexity. And then just later, this cost me 17 minutes. Yeah.
Right, exactly. So it kind of it definitely screwed you here. And yeah, it's like every single time there's always like a small mistake that kind of costs you big, and that's kind of the theme with a lot of people. Don't get me wrong, I'm not picking on you specifically, but almost everyone will have like one fuck up that costs them the biggest amount of time. Now the question is whether or not you can systematically work around that. That even if you fuck up like that, your process for solving will still be able to get you to an answer. And in this case, I would argue that the fact that you're like so stubborn and not trying to generate examples was probably the thing that to really look out for as well. So
Good.
So that was my feedback to you. I think you want to definitely write that down. Remember to be a little bit more flexible and generate examples. So, is there any other questions so far?
No, I don't think so.
Okay. Yeah, I want you to for the next few days. Let's talk about what I want from you for the next few days. So I want you to be able to focus on the midterms, right? And I want you to focus. Second one, I want you to focus on trying to do some lead code problems where the pattern's not super obvious. So for instance, I think some of the greedy problems are going to be up that alley. So it's
okay.
Yeah. So the greedy ones you need to figure out how to derive it and under what steps to do that in. But I think once you do that, you should have a clear idea of where the weaknesses in your approach are.
Okay. Actually, the midterm is tomorrow, so
get some sleep. I know we're not gonna do this till like after the midterm and Thursday anyway. So.
Okay. Any specific things for tomorrow, like before the day before the interview, or no?
For the day before the interview, I would say definitely try to relax a little bit more. I think for most people, like the day before the interview, nothing you're gonna do is gonna really change the result dramatically. At least you're aware that this generating example tool should exist in your tool belt. But for the most part, I want you to take that day off to kind of relax R&R, and just kind of like walk away from the computer, spend some time outside, hang out with some friends. I think that's almost always been like the best solution, I think. For
okay. Like, so my hangout with friends is gonna be do the midterm, basically.
After the midterm, if that's the case, then sure. And then at night, try like one or two examples. Really try to make sure you remember all the stuff in your toolkit. I think you said your interview is on the 20th, yes?
No, it's on the 19th.
Oh shit!
So
I have it written down.
Yeah, tomorrow. Yeah, tomorrow. Yeah.
Okay, so after the midterm, yeah. After the midterm, kind of chill with your friends, I think, because I don't want you stressing about the midterm and then stress at the night about the interview. So, yeah, I think the best thing to do is just really chill, and just keep in mind that, and just keep this one thing in mind. That make sense?
Great. Yeah, that makes sense. And then I'll actually go back and redo this this example with these things in mind in the notes I just took. Okay.
Yeah.
I think that's it, man.
That's
nothing else.
That's it. And make sure you contact some recruiters after Microsoft as well. And then we'll discuss plans after there.
By the way, actually, on the 19th exactly, the Amazon recruiter said for me to email him because I'm gonna be not block anymore into their system,
Okay.
So.
Fine. All right, we might have another shot in the water for that, but let's consider Microsoft our do or die.
No, for sure. But I'm just saying, like, maybe Amazon, because he was very interesting in my profile. Anyways, okay.
Sounds good. Get some rest and good luck on the midterm tomorrow.
Good, man. Thanks.
All right,
and bye.
Bye. All right, cool. Let's see what people said. You do Microsoft tagged LeetCode questions. Yeah. I mean, in general, that's kind of like what I recommended anyway. Do some LeetCode questions because those are gonna test. They're gonna spot check you. I'm assuming I'm not trying to study something not hardcore case in Verisol. Just get your resume reviewed for free and do interview prep. Yeah, I would say like the resume stuff is, I don't know. It's a little bit tricky because if you get the wrong advice, your resume kind of gets fucked. And I mean, me and Breadcat Bounce in the Discord server will actually do a spot check for free, but fundamentally, if you have like some fundamental issues, we'll tell you. So make sure that your interview gets reviewed by someone who is knowledgeable, not like free random people who fucking don't have any credentials on the internet. Do I like Algo Expert? I've made this clear before that a good source of knowledge will be consistent in how it approaches problems and how it solves them, and that's where you really learn. We call this the thought delta, and you might have seen it in like a past coaching session, but essentially we really just focus on that, and the closer we can get to the books, thought delta, then we clone the book, and this book is written by a bunch of senior and staff engineers, so this is the closer we get to emulating their thoughts. So in other words, Algo Expert I don't think does that, so I can't really recommend it, but if people find that it's useful, then more power to them. Do they care if you're taking notes? I don't know what that means. Like, who is they? Is it hard for a new grad with some internship experience and robotic experience to get a full-time job at tech job? No. In fact, if you have internship experience, it should be a lot easier than most people. I would ask people on Discord servers. Yep. Only two pairs. I'm glad to see Mr. Shout out to Mr. Mystics actually. He actually did the problem alongside M here. I think honestly, like being able to um, work on problems while we're doing it here. You see, like I actually do answer and talk to the chat if you do the problems and have questions about it. So I think shout out to you, man. You're getting a lot out of these coaching sessions by doing that. Yeah, hit me up, man. I'm interested in chatting with you in the Discord. Yeah, I really appreciate you doing this actually, even though it's like for your own benefit. But the fact that you actually do the problems, like it shows that hey, maybe there's something I don't think about, and there's something that maybe you have a better way of thinking about these things. Because I kind of pulled this problem. I haven't given this problem in a really long time, so it's kind of hard for me to remember how to do the problem. And then I kind of looked through the solution like after 5 minutes, like oh yeah, I remember the step by step. And so maybe there's some part of when I do the interviews that doesn't make sense. So people doing it in the chat, I really appreciate that. Shout out to Gerald too. Yeah, if you're doing the problem too, Gerald, then shout out to you, bro. Yeah, Mr. Mitz, you pretty much pegged it. Although I don't think you need to delete from the right to the left. It's more just there's two ways to solve the problem. The first one is the greedy solution. The second one is with a stack, but I think it's along the same vein. And so let me briefly explain the solution. Although I think he basically got it. It's just going from left to right, and if you encounter another digit that is smaller or greater than the previous one, then that you have enough runway left in the string, then you evict it. This is where the stack actually helps you. And then you have some corner cases like what if the digits are all the same, like 1 1 1 1 1. Then you kind of end up in a fucky scenario, and you do need to handle that. But other than that, the core idea is exactly the same. Case smaller string is an edge case, yeah. But I kind of gave you the solution, or at least the premise that you can assume a valid form of k. Final answer really is n minus k, because once k deletions are done, you're basically done. Yeah, that's correct, because you're doing a linear n time, and then in order to iterate through every single array, and then minus k in order to do that. But then when you and then you pop all the elements out of the stack, that's n minus k time, because you can only have n. Well, actually, you can only have n minus k elements in there, so yeah, that works. Man is perfectly explaining the testing process to catch the greedy idea. Yeah, it's basically, this is in general, actually. It's not specific to greedy. It's more just a, hey, know when to fail fast. It's like, if you came up with, like, the tree idea, and you came up with n to the k, yeah, that's basically what it is. And so you really shouldn't pursue the tree idea unless there's something that fundamentally changes the tree. Like, it prunes a significant number of the branches that you have to going forward. Like, each iteration prunes a future branch deterministically, except for the fact, and in this case it didn't apply because, of the various conditions like we ran into. And that's why I kept saying you're putting the cart before the horse in a lot of these examples. So that's why, like, I think that would have been the biggest hint to not pursue it. Google has a free video on resumes and what bullet points should say. Yeah, the thing about with a lot of resources out there is that they describe the symptom, but they never tell you how to get there. That's the thing. It's like, well, a good analogy is like if I told you Michael Jordan basically shot over half his points from inside the paint. If you look at all the data, he basically shot, I think, 47% of the time. No, maybe like 70%. I don't remember the stat. I think there was like an ESPN video on it. He basically like would go into the key and then shoot for his mid-range shots. And so the thing is that, yeah, everyone's gonna think, oh yeah, if I want to be like Mike, then I'm gonna shoot all my half my shots from inside the paint. Well, that's great and all, but then how do you get inside the paint when you have like two people defending on you? You know, it's basically just like that. Even though you know that piece of information, it's useless if you don't know how to set yourself up for that position. So that's why I have some problems with like a lot of the information out there. It's like, yeah, it's like symptoms, and basically you need to be the doctor trying to figure out what the cause is or how to get there. So that's it. Any other questions from the crowd? Going once, going. I guess I'll give it a minute since there's a delay on the stream. I guess that's it. Okay, cool. I guess that's it for stream. We might have a stream on Saturday. I don't know, depending on how burnt out M feels. But hopefully we get like a little bit of feedback from Microsoft from that. So I'll announce later if we do have a stream. So thank you all for joining me. If you all want to follow me, check out the Discord. Link is in the description down below. And if you're looking for coaching, book me for coaching at eChantech.com. Thank you all for joining me. I really appreciate you guys showing up for me. Yeah, and have a good night. I'll see y'all later.